Welcome again to this presentation. This is where we discuss the question and answers in thermochemistry. Remember last time we ended on question 38. Today we are starting on question 39. Question 39, it has two sub-questions. Sub-question number 1 is asking to explain the difference between reversible and irreversible process. So as an answer, we have the reversible and the irreversible process, and you need to explain the difference between the two processes. Normally, a reversible process is a process that can be reversed. You have the initial state and you have the final state, and you can reverse from the final state to initial state. If it is possible to reverse from the final state to initial state, that process is called reversible process. Reversible process is a process in which you have the initial state, you move from the initial state, you move to the final state, then you can reverse the process from final state back to the initial state. That process is said to be reversible. If you can have a process where you move from initial to final state and you can come back from final state to initial state, in that case, that process is a reversible process. Now, what is irreversible process? Irreversible process, on the other hand, it is a process that cannot be reversed to obtain initial state. You only move from the initial state to the final state, but you cannot move from the final state to initial state. So irreversible process is a thermodynamic process that cannot be reversed to obtain the initial state of the system. So this type of process, when you have the irreversible process, they are also called natural process, because most of the process occurring in nature, they are not reversible, they are irreversible process. That is the reason why the irreversible process is also called natural process, because in nature the process they occur and they don't return to the initial state. Almost all the process that occur in nature are irreversible. You cannot reverse them to the initial state. So we have a reversible process when you have the initial state and then you are moving to the final state. You have initial state, you move to the final state, and you cannot move back to the initial state. In that case, we have a reversible process. So this is the first difference between the reversible and the irreversible process. One can be reversed back to the initial state, while irreversible cannot be returned to the initial state. Now, that is the first difference. What is the second difference? So imagine we are having a compression and expansion. So we have here a gas, and this gas can be compressed and it can be expanded. The gas can be compressed and can be expanded. That means a reversible process can be either an expansion, the gas expanding, increasing the volume. The gas is expanding, it means it is increasing the volume. The gas is expanding. And the reversible process, it could be also a compression. A gas might be compressed. A reversible process may be an expansion or a compression. Expansion means increasing the volume, and the compression we are decreasing the volume. The same as irreversible process can also be expansion. It can be also a compression. We have reversible expansion, reversible compression, and irreversible expansion and irreversible compression. Now, What is the difference between these two? When you have the reversible and you have irreversible, what is the main difference? How do you differentiate them? So we have seen that both of them, they can be either an expansion or they can be a compression. Reversible expansion, reversible compression, irreversible expansion, irreversible compression. So now let's see. When you have reversible process, it is a slow process. When you have a reversible, whether it is expansion or whether it is a compression, it is a slow process. So a reversible process is a slow process. When it is an expansion, it is a slow expansion process. The gas expands slowly during a slow expansion. While in irreversible process, we have a fast expansion. In irreversible, we are having a slow expansion. In irreversible, we have a fast expansion. The driving force is the pressure of the gas. Of course, when you have an expansion, the driving force is the pressure of the gas. Expansion, the driving force is the pressure of the gas. A compression, the driving force is the external pressure. When you have the compression, the driving force is the external pressure. Now look, when you have again a reversible compression, it is also a slow compression process. The driving force is the external pressure. We have a reversible, which can be either an expansion or it can be a compression process. And all of these processes, if they are reversible, that means they are slow process. A reversible process is a slow process. When you are expanding the gas, the driving pressure is the pressure of the gas. And when you are compressing the gas, the driving pressure is the external pressure. When you are compressing the gas, the driving force is the pressure of the gas. And when you are compressing the gas, when you are decreasing the volume of the gas, that means the driving force is the external pressure. So now, let's go to the irreversible. Irreversible, it's a faster process. When you have irreversible, also you have irreversible expansion, but should be a faster process. Here we have a slow process in irreversible, and the irreversible we have a fast expansion. Now, same as when you are expanding the gas, the driving force is the pressure of the gas. Irreversible compression, it is a faster process. A faster compression, then the driving force is the external pressure. So we can differentiate then reversible and irreversible process. One can be reversed to the initial state. When you have reversible, it can be reversed back to the initial state. Irreversible, it's not possible to reverse back to initial state. Then the reversible process is the slow expansion or slow compression, and while the irreversible process we have fast expansion and fast compression. Irreversible is a fast process, where reversible is a slow process, and you have reversible expansion and you have reversible compression. You have also irreversible expansion and you have irreversible compression. Now let's continue to see the difference between these processes. What is another difference between these processes? So let's start on the reversible expansion. We have seen that is a slow process because it is reversible. Reversible is a slow process. Irreversible is a fast process. Now it is a slow process. We are doing an expansion. That means the gas is expanding. We are increasing the volume of the gas. If the gas is expanding, we increase the volume. The driving force is the pressure of the gas. The driving force is the pressure of the gas. Here, the driving force is higher than the opposing force. So we have the driving force in expansion, which is higher than the opposing force. The opposing force is the external pressure. But when you have reversible, because it is a slow process, the driving force is higher by only a small amount to the external pressure. So the driving force, the F is the driving force, is higher than the opposing force by only a small amount. So we have an expansion, but the driving force is the pressure of the gas. The only difference, the difference between the driving force, the difference between the pressure of the gas and the external pressure, that means it is not too much different. The pressure of the gas is almost equal to the external pressure. The opposing force is slightly less to the driving force. So there is only a small difference, a difference in a small amount between the driving force and the opposing force. That means during calculation, we can use the pressure of the gas in replacement of the external pressure because they are almost equal. Here also, the external pressure is not constant when you have reversible expansion process. Now let's see what is irreversible expansion. Here we have reversible expansion. Now let's go to the irreversible expansion. So irreversible, that means it is a fast process. Reversible here, it is a slow flow process. Here, because the process is very fast, the driving force is much higher than the opposing force. That means the driving force, the pressure of the gas, because you have expansion, the driving force, the pressure of the gas is much higher than the external pressure. The driving force is far higher than the opposing force. And again, when you have a reversible process, you should know that the external pressure is always constant. When you are given the question to calculate, and you are having external pressure which is constant, in that case, automatically you have irreversible. Irreversible process means that the external pressure is always constant. Whenever you see that the external pressure is constant, in that case, you are having the irreversible process. So now, here the driving force is the pressure of the gas because you have the expansion, irreversible expansion, but the driving force, the pressure of the gas is much higher than the external pressure. And for reversible expansion, we are having the driving force which is almost equal to the opposing force or external pressure. Here again, for reversible expansion, we are having the external pressure which is not constant, while for irreversible process, the external pressure is constant. So then you can get the difference. Can you see the difference? Now let's go to the table now, which is showing the difference between a reversible expansion process and the irreversible expansion process. All of them, they are expansion of the gas, but one is reversible, another one is irreversible. Now what is the difference? We have seen that in reversible, it is a slow process, while irreversible is a fast process. Again, the driving force in reversible expansion, it is the pressure of the gas. And here also, it is the driving force, it is the pressure of the gas. Because we are doing the expansion. Now, in reversible expansion, because it is a slow process, the driving force is higher than the opposing force by only a small amount. Only a small amount. There is no much difference between the driving force and the opposing force, which is the external pressure. And here in irreversible, because it is a fast process, the driving force is far higher than the opposing force. So here there is no way to use the pressure of the gas in the calculation, but because the external pressure is constant, here we'll use the external pressure during the calculation. But here we can use the pressure of the gas because the pressure of the gas is almost equal to the external pressure. The pressure of the gas is slightly higher than the external pressure. That's what I was explaining you, that the pressure of the gas is slightly higher than the external pressure. While here, the pressure of the gas is much higher than the external pressure. Here in reversible, we have external pressure which is not constant. So, and here we have external pressure which is constant. In the calculation, then you can use external pressure. And here, the external pressure is not constant. We can use the pressure of the gas. In reversible expansion, we have the infinite change, and while in irreversible, we have the finite change occurring during irreversible expansion. Here also, because we are in expansion, the pressure decreases slowly and the volume increases slowly. Expansion increases the volume. The pressure decreases when you are expanding the gas and the volume increases. But because it is a slow process, this is a decrease slowly and the volume also increases slowly. But here in irreversible, because it is a faster process, that means the pressure decreases suddenly and the volume increases suddenly because it is a faster process. And here, because it is a slow process, the pressure decreases slowly and the volume increases slowly. And here, the pressure decreases suddenly and the volume increases suddenly because it's a fast process. Now, there is an equilibrium between the initial state and the final state of the system because you have a reversible expansion. A reversible should have an equilibrium between initial and final state because this process also should be reversed from the final state to initial state. So there is an equilibrium between the initial state and the final state. And for irreversible, because it cannot be reversed back to the initial state, there is no equilibrium between initial state and the final state. So we have seen that irreversible process, they are real process. Most of the process occurring in the nature, we have seen that they are irreversible. So that means irreversible process, they are real process, while the reversible process, they are imaginary process. So now let's see the difference between the compression. Now we are compressing the gas. We have reversible compression and you have irreversible compression. What is the difference between these two? Of course, reversible means a slow process. Irreversible means a fast process. We have a reversible compression. It is a slow process. The driving force is the external pressure. In all compression process, the driving force is the external pressure. Here also, the driving force and the external pressure, they don't differ too much. The driving force, the F, is higher than the opposing force by only a small amount. External pressure, again, here is not constant. So we can use here the pressure of the gas in the calculation because external pressure is not constant. So during reversible expansion, we have a fast process. The driving force is the external pressure, and it is the driving force is far higher. It is higher than the opposing force, which is the pressure of the gas. That means here the driving force is the external pressure, and it is much differ with the opposing force, which is the pressure of the gas. External pressure here is constant. That means during calculation in irreversible, we can use the external pressure, which is constant. But in reversible, we don't use the external pressure because it is not constant. In irreversible compression, we don't use the external pressure because it is not constant. While here in irreversible, we are having external pressure which is constant. During the calculation, then we will be introducing this using this external pressure. Whenever you see where in the question they tell you that the external pressure is constant, in that case, you will immediately know that you have irreversible process. So this is again the table differentiating reversible compression process and the irreversible compression process. One is a slow process, another one is a fast process. The driving force is the external pressure. Here also the driving force is the external pressure because you have compression. Compression, the driving force is the external pressure. Expansion, the driving force is the pressure of the gas. The driving force here does not too much differ with the opposing force, while here the driving force is very higher than the opposing force. Here also the external pressure is slightly higher than the pressure of the gas, so they are almost equal. Here there is a big difference between external pressure and the pressure of the gas. Here again we have seen that external pressure is not constant. Here external pressure is constant. We have infinite change in the system. Here we have the finite change in the system. Here also, remember, we have seen that reversible is a slow process. When you are doing compression, you are increasing the pressure and decreasing the volume. That means the pressure increases slowly and the volume decreases slowly in reversible. While when you are in irreversible, the pressure increases suddenly, and the volume decreases suddenly. There is an equilibrium between the initial state and the final state. Here there is no equilibrium between the initial state and the final state. Here we have the real process, irreversible process, and real process, and here we have imaginary process. So you can see the difference between the two. Now let's see the difference in the reversible and irreversible when you are having the work done. Now let's see. We have here from A to point B. You can see that the pressure is decreasing while the volume is increasing. That is an expansion. In expansion, we have the pressure decreasing slowly and the volume increasing in expansion. Then from B to A, we will be having the compression. The volume is decreasing during compression while the pressure is increasing slowly. The volume decreasing while the pressure increasing during compression. From A to B, we have an expansion, and from B to A, we have a compression. But we can see it is a slow process. That means this curve stands for a reversible, a slow process. We have reversible and irreversible. Here we have a slow process. We have a compression and the expansion. So now from this one, from A to B, we have reversible expansion, and from B to A, we have reversible compression. It's a slow process. You can see this curve shows that is slowly. We have a slow process. From A to B, we have a slow process, a slow expansion, and from B to A, we have a slow compression process. So now, this is reversible process. A reversible expansion or compression. Expansion from A to B and compression from B to A. So then, when you have from A, the pressure, when you have irreversible, the pressure decreases suddenly and the volume increases suddenly. The pressure decreases suddenly and the volume increases suddenly. What is this process? This is irreversible expansion. Irreversible expansion, the pressure decreases suddenly and the volume increases suddenly. In irreversible expansion. Now, in irreversible compression, what do we have? We have the pressure increasing suddenly and the volume is decreasing suddenly. So you can see here, we have irreversible expansion, and here we have irreversible compression. Pressure during irreversible expansion, because it is a fast process, the pressure decreases suddenly, the volume increases suddenly, because it is a fast process. And during irreversible compression, the pressure increasing suddenly, the volume is decreasing suddenly, because in irreversible, the process is very fast. But in reversible, we have a slow process. A slow process. Can you see the pressure decreasing slowly while the volume increasing slowly? In expansion, in compression, the volume is decreasing slowly in compression, while the pressure increases slowly. When you are compressing, we are decreasing the volume and increasing the pressure. But because it is reversible, this should occur slowly. This curve is reversible. The process occurring slowly. A slow expansion and a slow compression. Decreasing the volume is a compression. Then in irreversible, we have a very fast expansion, irreversible, and you have also a very fast compression process. So hope that you can differentiate the two. Now the purpose, you want to see the difference in the work done. What's the difference in the work done in this process? So now, if you check here, we have the slow process, and here we have a fast process. This is reversible expansion because it is slow, and this is irreversible expansion. Reversible, a slow process, expansion, and a sudden process, a fast process, which is irreversible expansion. Here we are looking for work done between reversible and irreversible expansion. All of them, they are expansion, but this one is slow expansion and this one is a very fast expansion. Now, what will be the area under the curve? Where do we have more area under the curve? Because the work done is the area under the curve. That means for this one, the area under the curve will be from here up to here. So the dashed line, we dash them here to here to here to here to here. That will be the area under the curve. This is here. So the dashed lines, see, all this area under the curve, that is what we call the work done. Remember, we have shown that the work done is equal to the area under the curve and is equal to minus PdV. This is the area under the curve. Now, this is the area under the curve for reversible process, because we are looking only for reversible expansion. We are looking here for reversible expansion only for area under this slow process. Now, what will be the area under the curve for irreversible? For irreversible, this is only from here to here. The area under the curve for reversible is from here to here. The area under the curve for reversible. So that means this is the area under the curve for irreversible. Where do we have the high area under the curve? So that means that when you have reversible expansion, then you have a magnitude of work is higher in reversible expansion than the magnitude of work in irreversible expansion. Can you see that? The magnitude of work in reversible is higher than the magnitude of work in irreversible expansion. If you can see where, so this is reversible, and the area under the curve for irreversible starts from here. This is from here, from this point, from here, going down, we are having the area under the curve for irreversible. See, but for reversible, it starts from there. While for irreversible, we are only considering this portion, area under the curve for irreversible. So you can see that reversible has a magnitude of work which is higher than the magnitude of work in irreversible expansion. Here we are only dealing with expansion, not the compression. We will see the compression after. The magnitude of work in reversible expansion is greater than the magnitude of work in irreversible expansion. You can see the work done is there under the curve, and there under the curve for reversible, you can see is this one, and for irreversible we have only this area under the curve. You can see that the area under the curve. So for reversible, you add also this portion. See, this part is missing. It's missing for irreversible. But for reversible, it has this part, this upper part, plus this one. So that means reversible work done is higher than irreversible work done when you have an expansion. Let's see the compression. So compression, so here we have irreversible because it is the first, and you have the pressure increase suddenly and the volume decreasing suddenly because you have irreversible. And here for reversible, we are moving slowly. A reversible is a slow process. We are decreasing the volume slowly and increasing the pressure slowly. But here for irreversible, the volume, the pressure increases suddenly and the volume increases suddenly. The pressure is going to increase, the volume is going to decrease suddenly. Hope that you are looking good. Here, from here, we are increasing the pressure. The pressure from here, this is the first point for the pressure, and this is the point. We are increasing the pressure, but the pressure increases suddenly. What about the volume? The volume, we are decreasing the volume suddenly. The first point for the volume is this one, and the last point for the volume is this one. Increasing the pressure suddenly, decreasing the volume suddenly. That is what you are calling irreversible. Irreversible compression. Compression because we are decreasing the volume. The volume is decreasing suddenly, and the pressure is increasing suddenly. Then here from B to A, we are moving with slow process. We are decreasing the volume, but a slow compression. A slow compression is reversible. This is very, very fast. The pressure increases suddenly, the volume decreases suddenly. Now, what will be the two areas under the curve? Let's see. For here, for this one, the area under the curve is from here. We are dashing from here. That will be the area under the curve for reversible. Area under the curve for reversible, it will be from here. Yes, of course, this is here. But for irreversible, we need to start from here. We need to add also this part. That means we need to move from here. We need to include also the upper part in the dashing, the area under the curve for irreversible compression. So that means here in irreversible compression, that's where we have a high magnitude work as compared to the reversible compression. The magnitude of work in irreversible compression is greater than the magnitude of work in reversible compression. We have a high magnitude of work in irreversible compression and a less magnitude of work in reversible compression because the work is the area under the curve. The magnitude of work in irreversible compression is greater than the magnitude of work in reversible compression, which is different with when we were having the expansion, because we have seen that the magnitude of work in reversible expansion is greater than the magnitude of work in reversible compression expansion. Here we are in compression. The magnitude of work in reversible compression is greater than the magnitude of work in reversible compression. When we are doing compression, the magnitude of work in irreversible compression is greater than the magnitude of work in reversible compression. But when we are dealing with expansion, the magnitude of work in reversible expansion is higher than the magnitude of work in irreversible expansion. So here we need to understand the difference when we have the work in reversible and the irreversible expansion, and when you have the work done in reversible and the irreversible compression. We need to understand the difference between a reversible expansion, irreversible expansion, reversible compression, and the irreversible compression. Then how do we calculate? We move to the last point. How do we calculate the work done? The work done is calculated as the negative integral of external pressure times the change in volume. That is how we calculate the work done. The work done is calculated as the negative integral of the external pressure times the volume, dV. P external times the dV. But remember, in reversible, the external pressure is almost equal to the pressure of the gas. How do you calculate the work done in reversible? Remember, in reversible, we have seen that the pressure external is not constant, and the pressure external is approximately equal to the pressure of the gas. Then we can use the pressure of the gas in the formula rather than using the external pressure, which is not constant. You can use the pressure of the gas because it is approximately equal to the external pressure. So the work is equal minus integral the pressure of the gas times the change in volume. Now, how do you calculate the work done in the irreversible process? In the reversible process, we are going to use the external pressure. So we are going to use the external pressure. The pressure which is external is constant. The external pressure is constant, and here we are going to use the external pressure in the calculating of the work done.